Welcome once again to our commerce classroom. In this session, we will solve one problem by using our reciprocal services method. Before solving this problem, we know in our primary distribution, we distributed the overheads to our production and service departments. Then after that, we know our service departments, they have no manufacturing activities or no output. Service departments provide services to the production department. So we redistribute the overheads of our service departments to our production departments. That process is known as secondary distribution. In that secondary distribution, we have three methods for redistribution. First one, direct redistribution. Second one, step method. And the third method, reciprocal services method. This direct redistribution method and step method we already illustrated in our previous sessions. In this session, we deal with reciprocal services method. The peculiarity of reciprocal services method is this: we know service departments provides services each other. One service department can give service to another service department and at the same time get back services from the other department. This is the case of reciprocal services method. In our reciprocal services method, for redistribution of overheads, we have three methods. We can opt among these three methods. First method is simultaneous equation method. Second method, repeated distribution method. And then third method is trial and error method. Then here, firstly, we solve this problem by using simultaneous equation method, and then by using repeated distribution method, and then thirdly by using trial and error method. Okay, this is our question. A company has three production departments and two service departments. Primary distribution summary as follows: production departments A, B, C. A is primary distribution summary amount 10,000, B 7,000 and C 4,000. Then here we have two service departments X and Y. X primary distribution summary amounted to 702, then Y 900. Then expenses of service departments are charged on the following basis: A, B, C, then two service department X and Y. X, this shows in what way the overhead of X distributed among other departments. X 20% to A, 40% to B, 30% to C, and then 10% of X. Overhead of X is 10% goes to Y. Then Y's overhead distribution 40% to A, 20% to B, 20% to C, and then Y's 20% overhead goes to X. Apportion under reciprocal services method. Here we are using simultaneous equation method. The peculiarity of this case is this: in case of X, X is 10% of cost actually happened for Y, and then in case of Y, Y's 20% overhead actually happened for this X. This is the peculiarity of this case. Firstly, we solved this problem by using simultaneous equation method. Simultaneous equation method. Simultaneous equation method. In the simultaneous equation method, we have to form equations. Then We know the overhead of X as per primary distribution summary is 702. Then at the time of distribution of Y's overhead, X will get a 20%. 20%. Therefore, the total overhead of X is equal to this 702 plus this 20% of Y. So, I form an equation. Let X be the total overhead of this service department X, and Y, small letter Y, be the total OH of the service department Y. Then X is equal to, we know already the overhead distribution summary shows that X service department X is overhead 702. Along with it, it get at the time of distribution of overhead of Y 20% of Y. So 20% of Y. Then X is equal to, I rewrite it, X is equal to 702 plus 20% of Y, 20 divided by 100, that is equal to 0.2 Y. Then Y is equal to, Y is the total overhead, they already given by primary distribution summary is 900 plus, we know at the time of distribution of overhead of X, 10% goes to Y. 10% goes to Y. So 900 plus 10% of X. 10% of X. I rewrite this formula. Y is equal to 900 plus 10%. 10 divided by 100, that is equal to 0.1 X. 0.1 X. Then here we have 0.2 and 0.1. We have to remove its points from here. For it, we multiply both these equations by 10. Multiply by 10. Then our equation, multiply this first equation by 10. Then 10x is equal to 702 into 10, 7020 plus 0.2y. 0.2 into 10, then that's equal to 2y. Then the second equation, y. This equation we multiply by 10. Y into 10, 10y. 10y is equal to 900 into 10, 9000 plus 0.1 into x, then 1x. Then this is our equation number 1, this is our equation number 2. Then what we are going to do is this equation, reformat it in this way. This 10x, we shift this 2y from this is equal to, since this left side, 10x minus 2y is equal to 720. Then this equation, x in the first place, so minus 1x plus 10y is equal to 9000. I think this is clear for all of you. My intention is I want to get either this x or this y is equal to 0, then only we can solve this simultaneous equation. So I write this equation 3, this equation 4. Then what I want to do is, what we want to get is, we want to get either this y or this x to be 0. Then if we multiply our equation number 3 by 5, we get here 50x, then minus 10y is equal to, then this 7020 into 5. Then here this y will become 0. So multiply equation 3 by 5. Then we get here 10 into 5, 50x minus 10y is equal to this 7020 into 5. We get 35,100 This is equation number 5. Then this equation I write as it is here. Then we know minus 1x plus 10y is equal to 9000. I write it as equation number 6. Okay. Then in our next step we add these two equations. Then we get here this y0. Then 50x plus 1x is equal to add 5 plus 6. Then here we get 49x. Here we get 10x minus 10y plus 10y, that is equal to 0. That is equal to 35. Then 44,100. By solving this we get x is equal to 44,100 divided by 49. That comes to 44,100 divided by 49. That comes to 900. That comes to 900. So the total overhead of x is 900 after getting the 20% from y. Primary distribution table shows x's overhead is equal to 702. Then x get 20% of overhead of y. So that amount comes to the total overhead of x increased from the 702 to this 900. Then we find out the y. Y is equal to, for getting this y, we substitute the value of x here in this equation, equation number 2. Equation number 2 then 10y is equal to 9000 plus 900, that is equal to 9900. So y is equal to 9900 divided by 10, that is equal to 990. 9000 and not 9000, 990. Y is equal to 990. Before getting share from x, y's total overhead, that is equal to 900 as per primary distribution table. Then after allotting 10% of x to y, y's total overhead, that comes to 990. Then in our next stage we distribute these overheads we calculated now to the production departments A, B and C. I rubbed this portion. Statement of reapportionment or secondary distribution summary. Secondary distribution summary. In secondary distribution summary, first column for item, then second column for total, and then we have three production departments, A, B and C. A, B and C. Then first column we write the item. In this column we write the total amount. Then okay, we start from then firstly primary distribution. Then A is amount already 10,000 given, then B 7,000, then C 4,000. C 4,000, then it's a total 21,000. Then next what we are going to distribute the overhead of X among this A, B and C. Now we know we calculated the total overhead of X is equal to 900. Then A's share 20%, B's share 40% and C's share 30%. 20%, 40%, 30%. Then y share already we distributed to the overhead of y. Then 20, 40, 30. 20, 40, 30. Then we are going to distribute the 90% of this 900. We know already 10% of this 900 we allotted to the overhead of y. So 90% of 900. 90% of 900 in the ratio of 20, 40 and 34, 2, 4, 3 to this A, B and C. Then this 90% we know 810. We distribute this 810 in the ratio of this 2, 4, 3. 810 divided by 810 divided by 9, that is equal to 90. Then 180 to A, then 360 to B, and then 270 to C. In that way we distribute this overhead of total overhead of X. I repeat it. The total overhead of X is equal to, we already calculated 900, but we know that in that 900, 10% is already distributed to the overhead of Y. So the portion available for A, B and C, 20%, 40%, 30%, that comes to 90%. 20 plus 40 plus 30, that is equal to 90. So in this 900s, 90% is actually available for this A, B and C. 900 into 90%, that comes to 810. Then 810 we distributed in the ratio of 2:4:3. 180, 360, 270. Then in case of Y, we know the total overhead calculated for Y is equal to 990. But in case of Y, we know that the 20% of Y actually gone to the overhead of X. So the rest, the balance is 40%, 20%, 20%, 80% of this 990 into 80%, that is equal to 792. This 792 distributed among the A, B and C in the ratio of this 40, 20, 20. 4 is to 2 is to 2. 4 is to 2 is to 2. 2 is to 1 is to 1. Divided by 4 is equal to 198. 198 into here 198. 198 into 2 is equal to 396. 396. So 990 is 80%. 792. This 792 we distribute among production departments A, B and C in the basis 40, 20, 20. 4 is to 2 is to 2. That means 2 is to 1 is to 1. 2 is to 1 is to 1. I distributed it. Then we find out the total department A 10,000 plus 180 plus 396, that is equal to 10,576. Then for department B 7,000 plus 360 plus 198, that is equal to 7,558. Then for C 4,270 plus 198, that is equal to 4,468. 4,468. Then we write the total of this here 7,558 plus 10,576, that is equal to 22,602. 22,602. Okay. Then I think this simultaneous equation method is clear for all of you. We will solve the same problem by using a repeated distribution method. Then we solve this problem by using a repeated distribution method. In this repeated distribution method, we draw distribution summary. we have three production departments and two service departments, A, B, C, then X, Y. Firstly, we write the primary distribution summary. Primary distribution summary amount for A 10,000 and for B 7,000 and for C 4,000, then X 702 and Y 900. Okay, then in this repeated distribution method, we repeatedly distribute the service departments overhead among other departments. Firstly, we are going to distribute the overhead of this X. I write this as a negative figure. The 702 I am going to distribute among these A, B, C and Y. We know the base is 20%, 40%, 30% and 10%. X 2, 4, 3, 1, 702 divided by 10, we get 70.2. 70.2 into 2, that is equal to 140. 140 to A, then 281 to B, and then 70.2 into 3, that is equal to 211. 211 to C, and then 70 at 10% to Y. The excess overhead total as per primary distribution summary 702. In our first stage we distribute the 702 among other departments A, B, C and this Y on their distribution basis 20%, 40%, 30% and 10%. Okay, then in our second stage what we are going to do is the total of this Y. We know that service department Y 970 900 plus 70 970. Okay, this 970 we will distribute among other departments. These are A, B, C and D. Then Y, their basis of distribution 40, 20, 20 and 20. 4, 2, 2, 2. 4 is to 2 is to 2 is to 2. Then 970 divided by 10, 97, 97 into 4, that is equal to 97 into 4, that is equal to 388. Then 194 to B, then 194 to C and then 194 to X. Okay, then now here in the service department X in this column we have 194. Then we distribute this 194 among A, B, C and Y in the ratio 2:4:4. Then 194 divided by 10, that is equal to 19.4. Then 19.4 into 2, that comes to 38.8. I rounded it to 39 in case of A, and then it's double 77.6. I rounded it to 78 in case of B, and then 19.4 into 3, that comes to 58.2. I rounded it to 58, and then 19 to Y. Then here in the column of Y we have this 19, so we are going to distribute this 19 among all other departments. Then Y is 19, we distribute it in the ratio of 4:2:2. then 19, 1.9, then divide, then 1.9 into 4, 1.9 into 4, that is equal to 7.6. I rounded it to 8. I rounded it to 8. Then 1.9 into 2, that comes to 3.8. I rounded it to 4. Then again 4. Then balance 3 to x. Then here in the column of x we have these 3. We have these 3. I am going to distribute it among other departments. Then x 2 is to 4 is to 3 is to 1. Then I am going to distribute to this 3. Then 1 given to this a, 1 given to this b, and then 1 given to this c. Then this x last balance minus 3 distributed among a, b and c. Then we have nothing to distribute here, so I am going to take the total of these columns. Then a is total 10,000 plus 140 plus 388 plus 39 plus 8 plus 1, that is equal to 10,576. Then b 7,000 plus 281 plus 194 plus 78 plus 5, that is equal to 7,558. In case of c, 4,000 plus 211 plus 194 plus 58 plus 5, that is equal to 4,468. 4,468. This is the total we find out by repeated distribution method. Then I explain you once again what we did here. Firstly, we write the primary distribution summary given by already given 10,000, 7,000, then 4,702, and then this is 900. Then after that we repeatedly redistribute the service departments overhead among all other departments. Firstly, we take the 702, so I put one minus sign here, 702. I distributed this 702 among A, B, C and D in their proportion 2 is to 4 is to 3 is to 1. 2 is to 4 is to 3 is to 1. Then we get 140 for A, 281 for B, then 211 for C, and then 70 for this Y. Then after that we distributed the overhead total of Y among other departments. Here already Y 900, then we distributed 70, then total comes to 970. We distributed this 970 among all other departments in the ratio 4 is to 2 is to 2 is to 1. Then A got to A, that 388, Y 194, then C 194, and then X 194. Now we have in the column of X 194. We distribute this 194 among other departments in the ratio 2 is to 4 is to 3 is to 1, then 39, 78, 58 and 19. Now we got 119 in the column of Y, then 19 of Y distributed among other departments to 4 is to 2 is to 2 is to 2, then 8, 4, 4, 3, and then last we got this 3 in the column of X. We distribute this 3 among A, B and C to 1, 1, 1. Then we take the total of this column. This is actually the total overhead of our production department A, 10,576, then B 7,558, and then C 4,468. I think this repeated distribution method is clear for all of you. Our next method under reciprocal service method is trial and error method. Trial and error method. In case of trial and error method, we find out the total overhead of X and Y by trial and error. We know the primary distribution summary shows X's overhead total 702, then Y is 900, but we know in case of X it allowed 10% of its overhead to Y, and then in case of Y it allowed 20% of its overhead to X. So we have to adjust that percentage also to get the actual overhead of X and Y. That was the thing we did in our simultaneous equation method. Then here we are drawing trial and error table. Trial and error. Trial and error, we have two service department X and Y, then primary distribution for X 702 and then for Y 900. Then firstly we distribute the, we know in case of X 10% of it we allotted to this Y. So in case of X 10% to Y, we know the 10% 702, it's a 10% is 70. 10% is 70. Then now the total of Y, that comes to 970. Now what we are going to do is this, we know in case of Y it's 20% is actually charged to X. So Y 20% to X, 970 it's 20%. 194 we charged to this X. Now in the column of X we have this 194 here, 194. Then what we are going to do is to charge the 10% of this 194 to Y, that around comes to 19. Now we have 19 in the column of this Y. 19 in the column, we are going to charge the 10%, 20% of this 19 to X, 20% of this 19 to X, then 20% around comes to rupees 4. Then now we have rupees 4 in the column of this X, then X distributed 10% of it to Y, then 4, it's a 10% that comes to around rupees 1. Okay. Then we take the total of these column. We total the non-bracketed figures here. These bracketed figures we already allotted. Then 702 plus 194 plus 4. That is actually the total overhead of X. 702 plus 194 plus 4. That is equal to 900. 900. That is the total overhead of X. Then total overhead of Y, non-bracketed figures, 900 plus 70 plus 19 plus 1, that is equal to 990. So X's, in case of X, service department X is the actual overhead that comes to 900, and then Y 990 after getting the share from other service departments. So then now we distribute this 900 and 990 to our production departments by preparing secondary distribution summary. Secondary distribution summary. Here we have firstly an item column, then we want to have one total, then we have three production departments, A, B and C, three columns, A, B, C, three columns. Okay, then we start from our primary distribution, total of A, B and C. Primary A 10,000, B 7,000, then C 4,000. C 4,000. Okay, then it's a total 10, 7, 4, 21,000. 21,000. Then X is actual overhead, we find out 900. 100 and then 4y 990 by trial and error method. Okay, then we distribute the 9 in case of x we know 20, 40, 30, 10% to y. That we already transferred it to y. So 900 into it's a 90%. 20, 40, 30, 90%. That comes to 810. We apportion it to A, B and C in the ratio 2:4:3. 2:4:3. 810 divided by 9, that is equal to 90. Then for A, 90 into 2 180, then 90 into 4 360, then 4 C 90 into 3 270, then Y it's the total overhead we find out 990, but we know 40 20 20 80% available to this A, B and C. 20% actually we transferred it to X. Okay, then 990 into 80%, 990 into 80%, that comes to 792. We distribute this 792 in the ratio of 4 to 2. We can reduce it 2 1 1 2 4 2 2, that is equal to 2 1 1. Among these A, B and C, 792 divided by 4, that is equal to 198. So 198 for B and 198 for C. Then for A 396. Then we take the total of these columns. For A 10,000 plus 180 plus 396, that is equal to 10,576. 10,576. Then for B 7,000 plus 360 plus 198, that is equal to 7,558. Then for C, that is equal to 4,000 plus 270 plus 198, that is equal to 4,468. 4,468. Then total, here also we have to write the total 21,000 plus 810 plus 792, that is equal to 22,602. 22,602. So this is the overhead, total overhead of this A, B and C. This is all about our repeated distribution method. Firstly, we solved the problem by using simultaneous equation method, and then secondly by using a repeated distribution method, and then thirdly by trial and error method. In all cases we got the same answer. I think these problems explained by me here is clear to all of you. We will meet again in the coming sessions. Till then, goodbye.